Right now, you are probably holding back a tiny bit of irrational rage. Or maybe it happened yesterday. You're sitting in traffic, or waiting for a table at a crowded restaurant, or just pacing around your kitchen, and you completely snap at the person you love most in the world. Just absolute venomous irritation over absolutely nothing. And then, 20 minutes later, you eat a handful of fries and suddenly you're a delightful, rational human being again. You just experience the deeply embarrassing modern phenomenon we call being hangry, but this isn't a modern character flaw. It is an ancient, highly tuned, and violently effective biological alarm. It is a survival mechanism older than writing, older than farming, older than our species itself. The question is, why did evolution decide that the best way to keep us alive was to make us turn into total monsters the second we miss a meal? To understand why you become a nightmare before lunch, we have to go back to the very beginning of the human operating system. And it all starts with the most demanding, high-maintenance piece of biological hardware on the planet, your brain. Your brain only accounts for about 2% of your total body weight, but it steals 20% of your body's energy. It is an absolute energy hog. And unlike your muscles, which can store backup energy and burn fat when things get desperate, your brain is a picky eater. It basically runs exclusively on one premium fuel, glucose. Simple sugars pulled from the food you eat. When you skip a meal, the glucose levels in your bloodstream start to drop. Your muscles don't care. Your liver doesn't care. But your brain notices immediately and it panics because, as far as your brain is concerned, a drop in glucose doesn't mean the DoorDash driver took a wrong turn. It means we are starving and we are going to die, so it hits the biological panic button. First, your brain signals your liver to synthesize whatever backup glucose it can find. But if that isn't enough, your brain realizes it needs you to take physical action. It needs you to go find food right now at all costs. But how does a lump of fat inside your skull force your conscious mind to get up and hunt? It floods your system with stress hormones. Your adrenal glands start pumping out adrenaline and cortisol. These are the exact same chemicals your body releases if you are being chased by a bear or if you step on a snake. Your heart rate goes up. Your blood vessels constrict. Your body is physically preparing for a fight to the death, but evolution didn't stop there. Because a panicked human isn't necessarily a focused human, deep inside your brain, there are genes that produce a chemical called neuropeptide Y. Neuropeptide Y is the messenger that tells your brain, hey, we are hungry, go eat. But here is the wild part. That exact same chemical, neuropeptide Y, also controls anger and aggression. The biological pathway for hunger and the biological pathway for rage are completely intertwined. Your brain literally uses the same chemical to say, I need a sandwich, and I am going to fight that guy. Same. Yeah, I'd pick the sandwich too, but to understand why this chemical overlap exists, we have to look at the world where it was forged. Let's jump back roughly 2 million years to the African savannah, to the era of early hominids like Homo habilis. Food on the savannah was incredibly scarce. Every single calorie was a battle. Imagine two early human ancestors out foraging. They both haven't eaten in 2 days. Their glucose is crashing. Ancestor has a mutation where a drop in glucose makes him feel lethargic, sleepy, and emotionally passive. He sits down under a tree to wait it out. Ancestor B has a brain that responds to low glucose by pumping him full of adrenaline, cortisol, and neuropeptide Y. He becomes hypervigilant, aggressive, irritable, and fiercely competitive. He will fight a hyena for a scrap of bone marrow. Ancestor A died quietly under his tree. Ancestor B survived, ate the bone marrow, and passed his aggressive genes down to you. Rage was a survival strategy. If you are starving, being polite is an evolutionary dead end. You needed to be aggressive enough to take food from competing scavengers, or even from your own tribe members if it came down to it. Hunger kept our ancestors alive, but here's what makes this so important. This aggressive alarm system didn't just stay the same. It got worse. Around 1.5 million years ago, a massive shift happened. Homo erectus figured out how to control fire. We started cooking our food. Cooking is basically digesting. It breaks down proteins and carbohydrates so your body can absorb a massive amount of calories with very little effort. This surplus of cooked calories allowed our ancestral bodies to do something unprecedented: grow a ridiculously large brain. Our brains doubled, then tripled in size. We became the smartest primates on Earth. But we also created a trap. By growing this massive, energy-devouring supercomputer in our heads, we became dangerously dependent on a constant, heavy stream of calories. We became fragile. A crocodile can go a year without eating. A human gets a headache and loses fine motor skills if we miss breakfast. Our big brains made us geniuses, but they also made our glucose crashes much more severe. Think about that. The very thing that makes us human, our massive, intelligent brain, is exactly what makes us lose our minds when we are hungry. But here is the problem. Fast forward to about 10,000 years ago, into the era of complex hunter-gatherer tribes and the dawn of agriculture. Humans are living in tightly packed social groups. We depend on each other for survival. We hunt together, we sleep near each other, we protect each other. If every single person in the tribe turns into a violently aggressive psychopath every time food runs low, the tribe will destroy itself. We would just murder each other at the first sign of winter. How did we survive our own hangry? Biology. We had to evolve a counterbalance. We developed complex social rules, food-sharing taboos, and a deep psychological reliance on self-control. We had to use the prefrontal cortex, the logical, reasoning part of our brain, to suppress the ancient, hangry lizard brain screaming at us to attack. But here is the catch. Self-control takes energy. Suppressing your urges, being polite, smiling at your boss, not yelling at your spouse, all of that requires immense cognitive effort from your prefrontal cortex. And what fuel does the prefrontal cortex use to function? Glucose. When your blood sugar drops, the very part of your brain responsible for keeping your anger in check literally runs out of gas. Your biological brakes fail, and we actually have hard scientific proof of this. In 2014, a researcher named Dr. Brad Bushman at Ohio State University decided to test exactly how hunger affects human relationships. He gathered 107 married couples. He gave each person a voodoo doll that represented their spouse, and a box of 51 pins every night for 3 weeks. The participants were told to stab pins into the voodoo doll based on how angry they were at their partner that day. They did this in secret, away from their spouse. At the exact same time, the researchers were measuring everyone's blood glucose levels. The results were wild. It didn't matter how much they claimed to love each other. It didn't matter how good their relationship was on paper. The people with the lowest blood glucose levels stabbed significantly more pins into their voodoo dolls. Some of them used all 51 pins. When they were full, they were deeply in love. When their blood sugar crashed, they literally wanted to stab their spouse, and the study went further. After 3 weeks, they brought the couples into a lab and let them blast their partner with awful, painfully loud noises through headphones. Once again, the hungrier the person was, the louder and longer they blasted their spouse with noise. The science is definitive. When you are starving, your brain loses the chemical ability to regulate its own aggression. Today, we live in a completely different world. You aren't wandering the Pleistocene savannah looking for a gazelle carcass. You are surrounded by grocery stores, drive-thrus, and refrigerators. We live in an era of unprecedented caloric abundance, but your brain doesn't know that. Your brain has the exact same software as that hominid 2 million years ago. When your lunch is delayed, your brain doesn't think, "Oh, the restaurant is busy." It thinks, "The crops have failed, the winter is here, and we must fight for the last remaining scraps of food." So here's the full picture. Millions of years ago, your brain evolved to run on a highly specific sugar fuel. When that fuel dropped, your body flooded itself with stress hormones to force you to find food. As our ancestors learned to cook and grew massive brains, our dependence on those calories became critical. And today, whenever you miss a meal, the logical part of your brain literally powers down, leaving an angry, starving primate in charge of the controls the next time you are sitting in traffic or waiting for that table. And you feel that sudden spike of irrational venom bubbling up toward the person sitting next to you. Give yourself some grace. You aren't a bad person. You are just a fragile, high-performance ape running low on premium fuel. Eat a French fry. It's what your ancestors would want. If you want to keep exploring the weird, ancient wiring that drives everything you do, stick around. There is always more to the story.